So last time we see how to pick up weapons, how to add them in a list and remove them when we pick up a new one. I've also give you some homework about the helmet, but we're going to do that in the end of this video. Let's talk about what are we going to do today. We're going to do some basic enemy AI. As you see, I've already made a copy of my character over here. Now this is going to be fairly basics. We're going to make our enemy walk into one waypoint, and when it reaches there, it will go to the other, and then back again. And we will also add a sight to our enemies, and when our character enters the site and he's in front of the enemy, then he will start shooting to him. Now on the next video we're probably going to make this. We're going to take the foundations we set up here for our basic AI, and we'll make it an advanced AI that's going to be more fun to play. So let me stop there. I've duplicate my main character, and this character is the same, but with the user input I deleted the user input. As you see, all the other stuff are exactly the same. Now, before we dive into a script, we need to have two empty game objects. The first one will be the nav message agent, and we need another one that we will call site. Now for site you could put it on his head, but it doesn't really matter. We only use it to see if our character enters a trigger or not, and do all the other stuff. We do it from the enemy, from the parent. So to our nav message agent we need to add the nav message agent, of course, and for now the only thing we need to add is make sure we have a stopping distance, something that because we are using floats it's not that accurate, so I'm giving it something like 1.2 so that it doesn't tweak around, because he's right in the center of it. Now from all the stuff over here you might want to take auto braking off, and for now that's just it. Of course, for a nav message agent to work you also need to go to navigation and have baked a nav mesh, the nav mesh over here. You set up the settings you want over here and click bake. For the most part they will actually be correct or do for your work. If it doesn't, then play with these settings over here, go to the documentation, to the manual, and see what can you do. So let's go back to our enemy. Our nav message agent is correct, so let's go up to the parent and let's add a new script, which I'm going to add it over here. I will call this enemy AI, although we can use the same script to move and to move AI characters in general. Let me open it. Let's wait for Visual Studio to open. Let me close this, we don't want them. Let me zoom in. So I know from the start that I'm going to use lists, so I will add the generic namespace and the link. And now we of course know that we're going to have a reference to the nav message. Next we need a reference to the character movement, which I've called character move. And then let's have a game object that holds all our waypoints, so we call this waypoint holder, so we're not dropping them from the inspector. Next, a list that has all our transforms, all the waypoints, and we initialize this. And we need a float, so that is our target tolerance. So you can make this public if you want. I won't. This is how far must be the target for him to turn and go to that target. Let me delete these comments over here. So next we need the target position, where we need to go. Let's add the waypoint index over here also. This that will help us move through our list. And for now let's add a reference to the animator and a reference to the weapon manager, and later we'll come and add more stuff to it. So on start we need to get the component in children, and that is the nav mess agent. For character move we know the component is on the parent. The animator, the weapon manager, and now we will create an array that takes all the components in children, so we know all the children, even though they are empty, they have a transform component. So then, since we have all our transforms, all the waypoints have a transport, we simply say if the transform is not the waypoint holder dot transform, then waypoints dot add the transform. and then simply on. Before we write the update function, let's go and write a new function that's going to be the patrolling. So over here, our agent dot speed equals, let's give it something like 1, and we will say if waypoints dot count is higher than 0, so we know that we have a waypoint, and we'll say if agent dot remaining distance is lower than the agent stopping distance. Now we forgot to add some more variables over here, so I'll add a patrol timer, and let's go back now, and patrol timer we increment by time dot delta time, and we'll say if patrol timer is higher or equals than let's make it also public so that we can change it, but let's just initialize it from here. So if the patrol timer is higher than the waiting time, which for now it's 4 seconds, we will say waypoint index. If the waypoint index is equals the waypoints to count -1, then the waypoint index will be 0, else add to the waypoint index. Reset the patrol timer, and if the agent is not near the stopping distance or under the stopping distance, we also want patrol timer to be 0, and we want to manipulate the position of the agent so that it's always beneath our character, and the agent's destination will be waypoint index dot position. Now, because we know we calculate, instead of calculating the moving input where the player has it, we need to calculate some way the velocity our character will have, and that is simply the agent's desired velocity. Now, because it is patrolling, it's not something we don't want him to run, so we simply multiply it by 0.5, and after we have all this, we call the character dot move. We have a velocity, we don't want him to aim, and we pass the target position. So this, of course, we need to drop it over here. Now let's go back into Unity and see what we have done, unless we forgot something. and yes, we did. And we forgot, when we have a waypoint, we have our logic over here, but we need to add, now even though it's basic enemy AI, you see that the scripts are not at all basic, depending on your experience though. So we still need to manipulate the position of the agent, and we want the look position. We need a new vector 3 which we'll call look position, and that will be a check that if we had waypoints, then we want him to look towards waypoint index dot position. Else we want him to have a zeroed in vector 3. And since we are stopping, even though we are stopped, we still need to pass values to our move function. So we pass a 0, false, and this will be the look position. Now let's go back into Unity. Let's create an empty game object somewhere around here. Let's call this waypoints, and let's add some children over here. We call this one waypoint 1, waypoint 2. Let's duplicate that. Let's change, maybe I delete all this, change the icon over here so that we know and we can visualize it. Oops, wrong. And let me duplicate this. We want the 6 to be, let's make him go from there, over there, now this, of course, as you see, it's correct. If this was somewhere over there, this will cause problems because our agent will never be at that height, so it will never be close enough to take it into account. Now even though I put them on a line, it doesn't matter, the agent can find his way around, but you will notice that in corners you might have some unregular, how you call it, unregular movement. So I'm dropping the waypoints to the waypoint holder. We don't want this to be maximized. I'll drop the game view over there, and let's see what he will do. And as you see, he sits to the first waypoint, move to the second one. Now he does some stuff like that. Move to the third one. Now this is probably something going wrong, probably something with a rotation. So let's see if we can spot it. let's, instead of changing this, let's just say, let's give him a different position to look. He sits for 4 seconds, moves to the next one. Let's turn auto braking. Let's make the stopping distance higher or lower. Now this did fix some stuff. He waits for 4 seconds and then he will move. He will probably move to the next one. Probably stuck for some reason. Let's make his capsule collider to be a trigger. So anyway, that didn't do anything, so I'm just dropping the look position, and let's see now what else to do. So now we have a patrol state, but we need, even if our character goes in front of him, of course, we don't have a logic. Our character, our enemy doesn't have any sight and won't really do anything to us. So let's fix that. First off, we need to go to our site. Let's add a sphere collider. We want to make sure it's a trigger collider, and the radius, let's give him something like 10, 15, something like that. Now we're going to add a new layer, or yes, and on this layer we simply call it, let's just call it site. This is for when we're doing a recast, we mask out this collider so it doesn't so we don't hit that collider instead of hitting this collider. Now on our site we need, I'm going to add it over here, we need to create a new C# script which we'll call site script. Let's drop it in our site. And over here, this is going to be a fairly simple script. We don't need the update, but we need the start, so we need a reference to the character stats so that we know our character, the ID of our character, and a reference of course to the enemy AI. Now on start we need character stat equals get component in parent character stats, and enemy AI equals get component in parent enemy AI. Now before we start adding more to this, let's add some variables over here. and we know we need a public list with game object, which we'll call enemies. We initialize it, and now from all these enemies we, of course, let's make it public, it doesn't matter much. From all this, from the list of our enemies, we of course need an enemy to attack. So back to our side script, we will add on trigger render collider other. So when a collider renders, we first need to make sure that this collider is a character. And how we do this? We check if the character has a character stats component. If you remember, in the character stats component we check stuff for the ID of the character, and we will add some more like health and stuff like that. So every character must have a character stats component. And then, since we know it's a character, we check his ID and we compare it with our own ID. So instead of checking for tags, for player, enemy and stuff like that, we're doing it more dynamically so that we can have more than one enemy and they can fight each other without any trouble. And we can add however many characters we need to use. We can have them fight all of them each other, but if they have the same ID, then they won't see him. So we'll add if the enemy AI, if our list does not contains the other game object, then simply add it to that list. Now, of course, we don't want to keep looking to have enemies on our list that are not near us, so we simply say on trigger exit, if the enemy the AI from the AI our enemies list dot contains other dot game object, simply enemy AI dot enemies dot remove other dot game object. That's it for this script. And now, of course, we need not only to write what happens when when we spot an enemy. We need to write the decision to change from patrolling to attacking. Now, before we do that, let's write our decide state function. We need void decide state. Now, even before we do that though, let's add all our variables we're going to need, and that is we will decide by public enum, which we'll call AI state, and for now we will only have two, that is patrol and attack. We need to have to store this in a variable, and let's go over here, let's add some more public floats, and this we need an attack rate, let's give it 4, so every 4 seconds the character will attack. You can change this depending on difficulty, depending on the weapon the character the enemy has, but we will not do it now. So, and we need this, actually could be an internal variable, and now we have all this. Let's go to our decide state. So what we first need to check is if our enemies, we actually have an enemy close, and we do that by checking our list. So if there is an enemy into our list, then we have enemy close. But if we don't have an enemy to attack, so we're not attacking an enemy, then we need, for each game object, which I'm going to call NGO, standing for enemy game object, in enemies, we need to find the direction towards the enemy, and that is taking his position and removing and subtracting our position from there. And this way we find the direction the other character is. So we need to find the angle, since we have the direction, and we need to find the direction, the angle from the direction and our transform dot forward. And now that we have our angle, we can say if the angle is lower than 110f multiplied by 0.5, you can make the 110 a public float and change it from the inspector to what you like. I will not do that. And then once we are there, we can do a raycast hit and say if physics dot raycast, we need to give the origin. I'm going to give transform dot position plus transform dot up. It will be around the middle of our character. The direction we want the raycast to be, but we want this to be normalized. The out hit, and this should be the radius of our site. If I remember correctly, we had it at 15, so we'll give it 15. So if we hit a collider that is a character, and if you remember, we do that by checking if it has a character stats. And then let's take it all this, since it's the same. We check his ID, and if, and we haven't added the reference, so I'm just adding it here, which we compare it with our own ID, and if it's not the same, then we can simply say use a debug over here. Let's say enemy found, or let's just do this. I'm sure you understand it. So we can simply say enemy to attack hit.collider.gameObject. And now if so, this finds us an enemy, does a raycast towards all the enemies that inside our list, and if it finds one, it assigns us an enemy to attack. So be careful to put the else to the correct place. So if we have an enemy to attack, we simply say the AI state, we change the AI state to AI state dot attack. Now of course we need the attack state. Let's add a new function which we'll call void attack. So agent, the first thing we need to do is stop the agent. Now on the next video we will actually make him chase the player around, go towards, we will have a length that distance, a minimum distance we have before attacking and stuff like that, but right now we're simply going to do this like this. So we need to pass to the animator that he knows our character has stopped, because we might have he might have some values left, and those values, because we are closing stuff from our character movement. So I'm just simply manipulating the values from the animator and making him stop where he is. Now from the weapon manager we need to turn the aim so that our IKs and stuff like that work. To the character move script we need to make him stop, so we pass the 0 hit value, we want him to aim, so this will be true, and we do a vector3.0. Now once again we need the direction, so enemy to attack dot transform dot position minus r transform dot position float angle, so we need the angle, and we will say direction transform dot forward. Now we want to check for the angle, because we are going to using, if he's in front of us, we're not going to manipulate the rotation, we're going to use the IK to aim towards the player, and this needs dot angle. So once again we change the angle. If it's smaller than 110 multiplied by 0.5, then transform dot look at enemy to attack dot transform dot position. Now the way we do it over here, it might cause some problems, but we will take care of them as they appear. so don't worry. So attack timer, we need to add to our attack timer, and if our attack timer is higher than our attack rate, we reset the attack timer and call for the shoot array function, which of course we haven't made already. This will make an error, so we say refactor attack method, and so anyway, just copy paste it. So our shoot array is going to be pretty similar to the one we made for our player, but so I'm going to go fast with it. So we want to instantiate. Now we haven't added that to the weapon manager, so let's go do that. Weapon manager, import settings. So let's add to the weapon manager a public game object bullet prefab, and we can change this later to have to change with every weapon side script. So weapon manager dot bullet prefab, we want to have transform dot position quaternio dot identity, and all this will be as a game object. Now we know, oops, and now we know that our bullet prefabs have a line renderer, and we want to say to get that line renderer, and we of course know the static position will be a weapon manager dot active weapon dot bullet spawn, and we want this to change from local to a wall position. We want this the end position, and we will initialize it as 0, and we will do all the other stuff we have. Now let's have our mask. Let's bit shift it. So this mask, if you have more layers over here, it's somewhere. If you have more layers over here, and as you see, this should be at default. The first game object. The site should be at site. Okay. Since this was at site, even if we were shooting towards him, our ACAS will just ignore it and hit everything else, so we could never hit that. So be careful with the layer. So if you have more layers over here, you will need to find the appropriate integer, and instead of 9, use this. And then we need to find the direction to attack, and this is enemy to attack dot transform dot position minus transform dot position, and then we need to do a recast physics dot recast. We have our start position, we have the direction to attack, we have the out hit, we know to be math.infinity, and we pass the mask. Now this is probably exactly the same that we did on another video, so I'm just going to fast. We check the distance, we weapon dot bullet spawn dot transform dot position yes, we check the position from the bullet spawn point to the hit dot point. Then we do array cast hits, so physics dot recast all start position hit dot point minus start position and for the above distance. And now for each recast hit 0 in hits, we check what we hit, so if what we hit has a rigid body, then we find the direction, normalize it, and then we add a force to it. I'm just giving a 200 value over here, and then not else if it's a destructible, if it has a destructible component. If you remember, we simply did we destruct that. Now you can add an else if over here, but I'm not going to do that. We're not going to do that for this video. We'll do it on a later video. You can say if so with this you know that you hit a character, and you can add whatever you want to do when we are hitting a character. Now that outside of our for each loop, we will say end position equals hit dot point, and we will start setting the position for the line. So line dot set position 0, we know it's going to be the start position, and line dot set position 1, and this will be the end position. And this is how our characters, our enemies, are going to shoot. Now, of course, let's go and set up the IK also. So on animator IK, if you remember, everything that has to do with the IK, the built-in IK, must go inside on animator IK. So if we have an enemy to attack, then you simply say anim set the look at weight to be 1, can do 0.8, and all this to be 1, 1, and 1, and then the set look at position will be enemy to attack dot transform dot position. If we don't have an enemy to attack, then we simply, this needs more arguments, so we simply disable the not set layer weight, set look at weight, and so now that we have all this, we have our attack, we have our shoot ray, we have a decision a decision function that changes state to state. The only thing we need to do is going to update and of course call the decide state function and use the result from there inside a switch statement that we'll simply say if we have the case of attack, call the attack function. If we are at state patrol, simply call the patrolling function. And I think we have everything we need. Let's see what we have over here. We don't have any errors. Let's maximize that. Now we need to drop the bullet prefab into the weapon manager, and let me try and find it, although I think we already have it. Yes, so this is the bullet prefab. I'm dropping the bullet prefab to our weapon manager, and now if I hit play and we don't have any errors, if I hit play, as you see, since I'm behind him, and even if I shoot him, doesn't happen anything, and for some reason he doesn't notice me, so we have an error. So let's see why. Let's go back to our scripts. Let me see why. Or maybe let's see how we can debug it without going through scripts. We know we are inside the trigger. Okay. So if we go to the enemies list, we could see that the enemies actually we don't have any enemies. And can you guess why? And I will tell you, of course, because we have the exact same ID to our enemy and to our player. So if I change the ID of the enemy to be enemy, so the enemy was watching it like we are allies. And as you can see, or maybe as you can see, he now aims at me, and he's actually shooting. Now there is one thing we forgot to do. Of course, even if I go very far away, he will keep shooting. But if I keep shooting, you will see so even if I shoot towards him, you will see that our bullets fall into the first spherical glider. Okay, you see that it falls to this spherical glider. That is because from our user input where we shoot, where we make our player shoot, I haven't changed the bit mask over here. I haven't changed this mask to be 9 instead of 8. Now you might not have this problem if you have fewer layers than me. And now if we hit play, and we start shooting, we can shoot at each other. Of course he shoots every 4 seconds and he's pretty accurate. As you see, if you go too close you have a problem like this, and this is because of the IK. So you can add a check if the distance is lower than something like this for him to do something other than just shoot there. On the next videos we will expand a lot more on this basic AI system by a lot, and we will make him actually have more states, and he can decide between each one and decide what happens at each case, and you can expand by yourself a lot more than that. Now, why we instead of using the tag system Unity has, why we use our own with our own ID, and that is simply because we can do, if we duplicate him, and let's make him go somewhere over here, and if I change his ID now to whatever that is, remember, because we are checking if it has the same ID like we do, otherwise he's an enemy. I'm going to stop the maximize play. If I hit play, now of course we haven't checked if somebody attacks him, one enemy, he won't turn to shoot, but he will only, and he's going to the wrong way. So as you see here, they start shooting at each other even though they are enemies. Now of course it's not the most ideal, it needs a lot more stuff to fix, but we will take care of those in the next video. This is a pretty good start, pretty good basic AI. Now, in most cases and most games, you will see AI even more simple than this. Okay, so this is pretty good. So even though I am going towards them, inside their view, they still keep shooting at each other because we haven't changed them to shoot and decide who's more threatening and stuff like that. And we will take care of those things in the next video. I think we are already near an hour. So on the last video I gave you some homework, quote in, quote out, that was to make your character wear the helmet. So I'm going to go fast with it. Now, as you remember, the same as the weapons, this item must have a pickable item in here, the script. It's exactly the same we wrote to the previous video, but instead of the item, instead of having weapon control, I've added a new script which is the wearable. I called it wearable item, and the item ID. The item ID, change it to wearable. I'm opening up the wearable, and as you see, simply we have our variables over here. If it's equipped, if it has an owner, and actually might not, yeah, you don't even need this. You only need equip position, equip rotation, the scale, the reference to rigid body, sphere collider, to the pickable item, and the animator from the parent, which you might not even need this, but we might need it later. So set up the references, is kinematic, okay. The scale, store the scale, always manipulate the scale, since we might have problems from moving from local to world scale. And if it's equipped, if the pickable item is, if the item we store our pickable logic is active in hierarchy, make the collider a trigger, make the collider kinematic, make the rigid body kinematic, and close the pickable item game object. The parent, go to the character stats, go to the transform that has the character stats. So we always know that is the root of our character. Take the animator and take the head. You can do more checks. You can do it like we did our weapons over here. Like if you want to wear it on a different place other than his head. Transform local position will be the equip position, and the local rotation will be the equip rotation. Now, if the helmet is not equipped, if it's not, the pickable item is not active in hierarchy, open it, make the collider to not be a trigger, the rigid body to not be a kinematic rigid body. And if the pickable item has a character inside, check now we know, now this is only for the user. So if the owner has the user input, since we know only a player can have it, you can simply check all this stuff. You can pick it up. The item will be this game object, and if there is not a character in trigger, and if the pickable item has an owner, if pickable item owner is our user input, you can not pick it up anymore. The item is null and the owner is null also. this is for the wearable item. Now of course we need to also go into set functions, and if you remember over here we have our case for the health, which I haven't added already. We have the case for the weapon and the case for the wearable, which is pretty simple, and it's simply if our weapon manager, now I had the weapon manager over here, I had it inside the weapon, but since it makes more sense to have it outside, since we are accessing it from more than one case. So if you have it under this, if you have this under this, simply cut and paste over here, because I'm using the weapon manager more like an inventory, so that we don't have another script, and because there is no need for another script anyway. So headgear, of course the weapon manager from the last video, it didn't have the headgear, so you need to add a public game object headgear to the weapon manager script. So, and we simply check if weapon manager.headgear is null, then is not null. So if we are already wearing a helmet, then simply unequip the previous weapon, the previous helmet, and then the parent of our item will be the owner, the player in our case. Equip, inform that the item that is equipped, and the headgear will be this item. And with this simply, let's duplicate it also. I'm going to remove the material from this, and not this, so that we know that we actually change. Now of course this needs a new one. And since we know it's metallic, let's hit play. I have one helmet and the other is actually far away, so I'm going to bring it more closely. So I have one helmet. When I go to the other, it changes the helmet. And the thing we forgot to do is take the previous weapon, the previous headgear, and change his parent to be null. And now it should work like it should. And now it works like it should. You can pick up weapons, we can pick more weapons, we can shoot, we can pick up helmets, and of course we can have enemies over here, and these enemies can shoot us. Now of course nothing happens, and we will take care of that on the next video, because I want to code more states than simply attacking. So we will add some checks. If the characters have a low health, they won't just sit there and keep attacking, but they will retreat. They will try and find some more enemies and allies, so that they can gang up on you, stuff like this. So that's it for today. We did a lot of stuff. Make sure you understand what we do. Next time it's going to be way more advanced and a lot of theoretical and a lot of theory. So make sure you have a good understanding of this basic stuff, and we can do some more cooler stuff in the next one. So support us on Patreon if you can. Don't forget to like and subscribe, and next time we will make this game even cooler.